In case you haven't heard, Omicron is here, and it is everywhere. It's reached over 100 countries at this point, and it's likely soon going to be in every country in the world. This is a COVID variant, but it's like none that we've seen before. It's spreading incredibly fast. In most places where Omicron is now, the total number of COVID cases are doubling in 1.5 to 3 days. So imagine you had 10,000 cases to begin with. In a little bit over a day, you'd have 20,000, then 40,000, 80,000, 160,000 in a week. In a month, you would have millions, and that is what's happening right now. In the UK right now, they found that people who have cold symptoms, so runny nose, fatigue, headache, 50% of those who have those symptoms are being diagnosed with COVID. 50%. And that's likely applying to many other countries now too. So in Canada, for example, if you have cold symptoms right now, and I'm sure a lot of people even listening to this do, there's a 50% chance that you have COVID. But so the question is, what does this mean for the world? A lot of people have been super worried about this for the past month and a half that Omicron has been around because it spreads so quickly. And even if it's more mild, if a small percentage of people who get Omicron end up in the hospitals, that could mean that the hospitals in every country all around the world would be completely overloaded. But now, as time is starting to go by, we're getting more data on it, and it seems to be that this is just not happening. Hospitalizations and death are barely going up if they are in countries, while cases are exploding. So it seems like what's happening right now is that almost everyone, including those who are vaccinated, may soon have COVID, which is crazy to think. But since this seems much more mild, it's possible that we could all just be sharing one giant case of sniffles at the same time instead of ending up in the hospital. Now, we don't know this for sure, and there's guaranteed to still be some sickness and some death, unfortunately. But it's starting to seem right now that this could be a potential way out of the COVID pandemic. Interestingly, what's happening right now may actually be what we would expect. It could be what naturally happens with viral evolution. It changes over time into something that is less severe. Now, there's no guarantee that that will happen, and you don't know what time period it would take for that to happen. It could be 10 years before a virus becomes less severe, but it seems to be following a natural evolutionary path that most scientists would expect. So I'm going to show a quick look at some of the data for Omicron now, just to get a better understanding of what is happening right now. But I also want to go into how viruses evolve and maybe help you understand how this natural process works. So I've only pretended to be an amateur epidemiologist for the last couple of years, like a lot of people. I'm not a real doctor, so you can obviously take everything that I say with a grain of salt. It's not medical advice. If you want some more kind of analysis of the data, you can take a look at Dr. John Campbell on YouTube, and I find he presents information in a really easy to understand way, but doesn't try to bias and lead you in any specific way to understand what's going on. So I want to explain how viruses evolve, but be first. Okay. So before I talk about how viruses evolve, I want to quickly explain a little bit of evolution in general. And I think most people understand evolution, but this could be a quick refresher course. Something that most people understand is that we look like our parents. We're very similar in facial features, for example, to our mother and our father. And the reason that is because the parents have something in them called DNA, which is sort of like a recipe that describes how their future offspring are going to look and what they're going to be like. So the mother and the father both have DNA, and together these recipes are combined to create the child. But we don't look exactly like our parents. There's always some differences. And part of the reason why is because these recipes don't copy exactly. So oftentimes there's variations and mutations that happen that are not in the original recipe. And these mutations have helped us and other animals evolve and change what we're like over time. Some of these mutations stick around and change us for the long run. Some of them do not. And there's a reason for this. Generally, the ones that stick around are the ones that help us survive. They help us live longer, and they help us procreate. Generally, if you live longer, you can also procreate more because you have more time to have babies. So a quick example would be if one of our ancestors was born with one leg much shorter than the other, there's a significant difference, and they were sitting around a campfire and they got attacked by an animal. They may not be able to run away as easily as someone with sort of even length legs, so they may not be able to carry on their genes and have children. So that mutation may not carry on to future generations. But there are some mutations that stick around. One example is the fact that over time, humans walked more upright and on 2 feet. This helped us because we were hunters. So if there was a deer and we were able to, say, throw a spear into that deer, the deer would be injured and would run away. The deer is quick though, so we can't chase that deer and catch them right away. But because we can walk and run on 2 feet, we can go really long distances super efficiently. So we could follow that deer for hours and hours until finally the deer collapses and we would have a meal. So the more humans that had that mutation to stand more upright could more easily get the meals and nutrition that they needed in order to survive and have more babies. So that mutation stuck around. Okay, so why am I talking about humans? This is a virus here. But interestingly, viruses evolve in a very similar way. So COVID doesn't have DNA, but it has something called RNA, which is a similar kind of recipe for how it has babies. So once a virus gets into someone's system, it actually kind of hijacks their body, their ability to replicate and create cells, and duplicates itself. And it uses the little recipe that's built into its RNA to determine how each copy is going to be. And it's trying to copy exactly the same, but oftentimes the copies don't work and there's mutations. A lot of times these mutations don't really go anywhere. They don't help the virus live any longer or procreate, but sometimes they do. And if there's enough significant mutations, then it can create what we would call a strain or a variant of a virus. And that's what Omicron is. It's significantly changed from the previous version. And if you're wondering where these ridiculous names came from, it's actually the Greek alphabet. So the Greek alphabet goes alpha, beta, gamma, delta. So that's number 4. The 4th letter was the 4th variant. But now we're at Omicron, which is actually number 15. So there was 11 variations between Delta and Omicron, significant changes that happened within the kind of viral code. But they didn't stick around. They weren't able to replicate and take over in the same way that Omicron did. But why was Omicron able to do that so well? It's because these mutations helped the virus live longer, it helped it spread and replicate itself much easier than Delta or any previous variants. So how did these mutations help it? Well, first of all, it seems to be able to multiply much quicker, and it mainly happens in the upper respiratory section of our body rather than the lungs. It actually replicates more slowly in the lungs. So that allows the virus to quickly replicate and quickly spread to new people. It also, in a way, is able to live longer and spread for a longer period of time because when people get sick with this virus, it seems to be more mild. So if someone is sick with a virus that is very severe and it forces them to not go to school, not go to work, to stay home and in bed, then they're not able to spread it because they're just not in as much contact with people. But if you have a virus that just kind of feels like a cold, maybe you just have the sniffles, you might not recognize that you have COVID or anything significant, and you go about your life and you spread the virus. Both of these seem to be what's happening with Omicron. And in a way, it's actually not that surprising because this does seem to be the natural progression that viruses go through over time. It's the strains that are less severe, that are able to spread more easily, And that allows that strain to win. It wins in the evolutionary battle against previous strains. So you can take the Spanish flu, for example, to try and look at another serious illness that took over the world. So if you haven't heard of the Spanish flu, it happened about 100 years ago in 1918, and it quickly spread throughout the world. It's estimated that it killed over 50 million people. So it's a huge amount of people that died, a huge amount of people that got infected with this. It happened over a period of about 3 years in multiple waves, and it's likely that these multiple waves were different variants of the original virus. But back then they didn't have vaccines, so they had no way to vaccinate people from the virus, which means they could not stop its spread. It just kept going. But it makes you wonder, what happened to it? Where did it go then if you could not vaccinate? Well, what happened is it didn't go anywhere. It's still here. The Spanish flu mutated and evolved over time and actually became less and less severe. So now if you get the flu in any year, it's possible that the variant of the flu that you have, because the flu has multiple variants, the one that you get could have came from the Spanish flu. And most likely you're not going to die from it because it's much less severe than it once was, but it's still around. It didn't go anywhere. And I think people have known for a long time that COVID was going to be the same way. It was going to be endemic, is what you call it, where the virus doesn't really go away. It's just in the system. And that eventually would become more seasonal, where it would just hit us every winter, for example. But we didn't know how long it was going to take. It could have taken 10 years, it could have taken 100 years, but it seems like it may be happening much quicker than we expect. So I'm just going to take a quick look here at some basic data to showcase a bit how severe it seems like this variant is going to be. So if you didn't know, the variant first became prevalent in South Africa. That's where it first exploded, and we were able to see that it grew so quickly in case numbers. So South Africa is the main place where you can look first to see what the long-term effect of it has been. And it's been over a month in South Africa now. So one place that we can look for data is Google. And I know that sounds ridiculous, but Google is able to pull in data from each individual country, and this is from their official sources. So you could take a look at COVID cases in South Africa, and they've got some useful data here. South Africa seemed to have followed a very stereotypical pattern where there was multiple waves and surges. So this is the total number of cases here. And you can see the first little bump, well, it's not really a little bump, it's a big bump, which is the original virus. And then there's another bump, which I think that was from the beta variant. And then the Delta variant was the most recent bump before the recent one. So they went down quite a bit. They didn't have a lot of cases. And then it shot back up. And this is from Omicron. Omicron cases multiplied way quicker than anywhere else. So normally what happens when there's a bump in cases is shortly afterwards there's a bump in the number of deaths. So we can see here we've got 1, 2, 3, 4 waves. And then if we take a quick look here at number of deaths, we can see the waves in the number of deaths. So it's interesting because there's 3 significant waves, but there's no fourth wave. It seems to have very slightly increased the number of deaths in the past few days, but it really hasn't went up much. You can look again at the cases, this big bump, and then nothing seems to have happened. Okay, so there's something to consider here though, because it's whenever you have a new case, someone doesn't immediately die, right? There's often a period of time between when someone first gets symptoms and when they pass away. So generally the period of time in between that is about 18.5 days. That's what it's been for previous variants at least. And often there'll also be a delay between when someone has symptoms and when the case is reported, because they're feeling sick and then they wait a couple of days and then they decide to get tested, and it takes time to process, takes time to get reported. So there's a few days in there at least. So I would say between once a case is reported and a death happens, on average, it's about 2 weeks. So what we would expect is a 2-week delay between number of new cases and deaths. 2 weeks is the average amount of time, but it's possible that someone could pass away after, say, 1 week. So you would expect to at least see some effect after about a week, but after 2 weeks, you're almost guaranteed to see an effect. So let's see, if we look at the peak of the number of new cases for Delta, we've got around July 6th. And then if we look at the deaths, it's a little bit later. It kind of peaks around here. There's like a week, 2 weeks, and then eventually it starts to go down, which is naturally what happens. So now if we look at Omicron, well, it began a bit over a month ago. So we can look around November 19th, let's say. And then it's shot way up since then. So even since like December 8th, there's been a huge amount of new cases. But then if we look at deaths, they just haven't went up. They're finally going up a little bit, but it's nothing compared to previous waves. Something that a lot of people weren't sure about was if South Africa would be able to extrapolate to other countries. So in South Africa, the population is pretty young. A lot of people have naturally gotten the virus. And actually, we know now that natural immunity is a bit better than vaccinated immunity. But either way, there was a possibility that there were some differences between South Africa and other countries. To some extent, that can be made up for through vaccinations, though, because in Canada, for example, we have over 80% of our population with at least one vaccination. And I think about like 78% who have two. So a huge portion of the population is vaccinated, and most of the elderly population is an even higher percentage. So most of the elderly people are vaccinated. But still, there's a possibility that it could be different in some other countries. So now we can see that the UK, Denmark, and some other countries, this variant is becoming the main variant. It's taking over very quickly. Actually, in South Africa, where we were just looking at, it is 98% of the cases, which shows that Omicron is completely taken over from Delta. That hasn't happened everywhere yet, but it seems like it's going to happen. So it's useful to potentially look at another country here. So let's look at the UK. First of all, they had a large amount of Delta from June all the way into November here. So that was what most of this was. And now we're seeing a massive increase in cases again, and that is from Omicron. Okay, but then we can look at the number of deaths, and we see the increase from Delta, but now it's not increasing with the new cases of Omicron. It seems to be going down. Another country where there is a lot of cases is Denmark. Denmark actually has reached their testing capacity, so they can't necessarily even report how many new cases there are. So if we look at the number of new cases, there was Delta again. So this was Delta here. But then we have Omicron going way up. And we can see an increase in deaths from Delta, but it seems to be leveling out, if not going down again. So it's interesting because this seems to kind of be appearing in every country where the number of cases are going up by huge amounts. Omicron is taking over from Delta, and number of deaths are actually staying the same or going down. And in a way, this makes sense because Delta is just more severe. It seems to be killing more people. So if Omicron is not doing that and it's taken over from Delta as the main variant, well, in the long run, we expect way, way less deaths. Okay, so you might be thinking, that's deaths, but what about hospitalizations? What if the hospitals get completely overloaded? Well, this also doesn't seem to be happening. In South Africa, where remember, they've had the most cases, where they actually seem to be potentially going down in number of new cases because they might have reached their limit, where essentially everyone has gotten Omicron at this point. Their hospitals did not get overloaded. They have, right now, I think it's about 9,000 people in hospital, which might seem like a lot, but this is a country of 60 million people. So it's actually very few. And of those people that did need to go into the hospital, they were staying for much shorter periods of time. They were much less likely to go into the ICU or to need oxygen. And the majority were not dying. And it's really interesting to see the world's response to this right now, because there's some very potential bad news in that it's spreading so quickly. And there's huge risks that if hospitals get overloaded, like it's just going to be way too many people. But now there's also lots of data coming in that's showing that, well, it doesn't seem like hospitals anywhere are getting overloaded. It's not happening in the UK or Denmark, in the US, every country where Omicron cases are spreading quickly, people are not filling out the hospitals. So how is a country supposed to react to this? Well, an interesting change that just recently happened is Australia significantly started changing their policies. So they've actually went to a place where they essentially don't have any policies. There isn't any restrictions that they're putting in place. They're following what would be considered a permissive strategy, or at least that's what they call it, where they're allowing the virus to exist. They're allowing people to continue going about their lives normally. And they're hoping and believing that if people see that virus cases are going up too much, that they might go out less. They'll be less likely to spread it, hopefully. And then if they find that cases in the hospitals are going up a lot, then maybe they'll put some restrictions on. But they've made a huge 180 turn on their restrictions, and now they've pretty much gotten rid of them, which is crazy to see. Now, I don't want to sound like I'm against restrictions. It's definitely a conservative approach, but maybe it's the best thing just to not take the risk in a short period of time. But I say short period of time because I think this is going to be a short period of time. It seems that because this virus goes so quickly through the community and through countries, that it also is dissipating just as quickly. And now South Africa's cases seem to be going down. So what I wanted to get across here is that this appears to be very positive news. It's positive because it seems that over the long run, many less people are going to die. It's positive because this virus seems to be following its natural evolutionary path to become something more like a seasonal cold than a pandemic. And because it means that we may soon be able to move from this pandemic mode of life that we've been living for 2 years into something that more resembles normal life. And that is some very positive news. So there still should be some caution. We don't know everything for sure. It's advised that we still try to interact with as few of people as possible so that there's not a massive spike too quickly in this new variant. And if we do feel like we have symptoms, that we should get tested and determine if we have the virus. If you have it, then of course you need to isolate yourself for a period of probably about a week. And remember that the symptoms have kind of changed from what they used to be. The symptoms that you might find now are a runny nose, a headache, and fatigue. Those are the 3 big ones that seem to be part of the Omicron symptoms. So if you're feeling those, get yourself tested. So let's all be safe. Let's get through this short period of time. And overall, I think it's some pretty positive news. Happy holidays.